Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we will do the binary search. Inside the binary search we have learned about 4 different types of patterns, and out of that we were doing the very first topic, which is classic binary search. In this today we will do the third question, which is search insert position. So let's read the problem statement. It says we will be given a sorted array of distinct integers and a target value. We have to return the index if the target is found. If not, return the index where it would be if it were inserted. Means the question is saying we will be given a sorted array, and out of that we have to insert a target value. If the target value is there, means we have to return that index where the target was found for the first time, means that will be the index for it. And if not there, then we have to return the perfect index for that where it would have inserted, such that after insertion also it will be a sorted array only. Okay, now let's see the constraint. It says ki num's length can go till 10 power 4. Okay, 10 power 4. Why we always read the constraint? Because we know beyond 10 power 8 the code might give us TLE, or it will be very slow, where we have to optimize it. Okay, now let's see the number can be negative also. Okay, so as you can see, the nums array have every integer value like in a sorted order. Okay, whenever the numbers are in sorted order, we can think of 2 pointers from the array perspective, or else if we can think of binary search for the optimization, but not for the brute force. For the brute force, we can think of running 1 for loop, 2 for loop, whatever, however it is possible. So let's see. We have to insert this target 3. Okay, we have to insert. So what do you think? We should insert from the right side or left side? Obviously left side. But how we will get to know? Because when we saw this, correct? So basically code does not know na ki this 3 should fit it where. Okay, so hence we will go the linear search. We will do the linear search, and how we will do? First we will start with this position, and we found 1 is there. So do you think we have to insert 3? And we have found 1. So 3 should be inserted towards right side, right? Yes. So hence we will move to the next I. Now we found it is 2. Okay, and we have to insert 3. So obviously 3 should be inserted towards right side. Now again we will move, and we found 4. Okay, wait. We are only moving one by one now, and we have come here only when the previous was lesser than the target. Yes. So if we found this number 4, so can we say that this 3 should be inserted at this position only? Yes. Yes. So can I say that if nums of I is greater than target, okay, is greater than target or equal to also, okay, so what we have to do, if this is a condition, we have to return the same, return ith index only, because we have to return the index only, na? Yes. But why I have used this equal to operator? Why? Because the question said na, even if you found the same target value present there, we have to send the same index. So hence if it was 3 and target is also 3, so we can say ki if target and nums of I is same, then we have to return the same index. So that is why I have put it the greater than and equal to operator. Okay, so hence if we found this, we will return this. But for this, so we have to iterate at every index na, one by one. So for that we have to close this in a for loop. So yes, let's close this. Int I is equal to 0, I less than nums dot length, let's say n, and I plus plus. And in this we can say if our nums of I is greater than, then we will return. Initially it was not, so we will move to the next I. Initially again not, now we will move to the next I. And hence we found this nums of I is greater than target. So we can say yes, this is a position where 3 should be inserted, so that the whole array will be in the sorted order only. Okay, or else if we don't found any such index, you say if we don't found any such index, suppose we would have inserted 10. Okay, so if we have to insert this 10 number, definitely for this no such element will pass, correct? And what do you think, where this 10 should be inserted? At the last index. Okay, last index. So can I say the last index is nothing but the size only? Because we know from 0 to n minus 1 the index is there, and we want to insert at last. So n minus 1 plus 1 means n only. Yes. So if we have not found anything, we can simply return nums dot length, or we can say n. So here you can see we have initialized the for loop for I is equal to 0 to nums.length, and in that I will check ki if anywhere I have found my nums of I to be greater than the target or equal to target, we will return that index then and there, or else after running whole for loop, if we have not found any such index, it means the target value which we have got is greater than the last value also in the array, and hence it should be added at the last. So in that case, we will simply return the nums.length. Now we can run this and you can see the time complexity, because only we are using one for loop, the time complexity will be O of n, and hence it will be somehow faster only, correct? As you can see, it is fastest because the time complexity was O of n and the constraint was 10 power 4. But what do you think? If the constraint was 10 power 9, will it run? No, I don't think so. Why? Because we know beyond 10 power 8, it might give us TLE, 9 into 10 power 8 or 10 power 9. It will give us TLE. So in that case, linear apply or linear search will fail if the constraint is 10 power 9. And hence you cannot submit this O of n code, correct? Then what should we do? Can we optimize it? Yes, we can. What optimization technique when the array is sorted? Binary search, yes, because we know if we will apply the binary search, it will reduce the time complexity from O of n to O of log n. Yes, yes. Now how can we apply this binary search concept? Okay, so you see, in binary search, we always compare with the mid element. Why only mid element? Because it helps us to reduce half part decision. Okay, how? See, the target is 3, and what will be the middle element? 0, 1, 2, 3, 4, 5, 6. Okay, so middle element will be third index, which is 4. Okay, so we will check this 4 and compare with the target, and we found that target is smaller than the mid element. Yes, means where should this target element would have been placed? Towards the left side or towards the right side? Of course, towards the left side. Hence, in this way, we can eliminate the half part of the subarray. Okay, now instead of searching in the right half, okay, in the right half, we will search in the left half. Okay, so left will still be there and right will be where? Initially right was here now, like mid was here now, and we saw that this is smaller than this also, correct? Hence we will move this right element towards the mid -1, and now we have to search in this. Now again the mid element we find here, and we saw that this is a smaller than target, correct? Hence we have to move our search towards the right half. So now from here, like from here to here, we want to search in the right half, means we have to search in this only. So left pointer will point to the same index, right pointer will point to the same index, and mid element will be also at the same index. And hence that was the position where 3 needs to be inserted, because when we find any one index, only one index left over, means that will be our final answer. So how we can write here? We know that we have to initialize our left variable with 0 and right variable with last index, which is nums.length, let's say n -1. And now we want to run this until our left crosses right. Until it is equal, we'll keep on running. Now what I want to do? I want to first calculate my mid element. Okay, so we will create our mid element. We can create in two ways, if you know. Left plus right divide by 2 also, correct? When it is of, like, it will be in the integer range. But when r is so big that it can go beyond the integer limit, then in that case we write like this: left plus right minus left divide by 2. Okay, why so? Because right is so big ki if you will add, like first you will add you will add that number and then only we will divide. So left plus right might go beyond index. Okay, now in that case it won't run. Okay, so hence we have to go with this, means even if the right is so big now, we will subtract the left index first and then divide by 2. And all these concepts, if you don't know, we have already discussed in our previous video. You can go and check it out. Okay, so as of now, let's see, we will divide, like we will calculate our mid element like this, and first we will check what if the mid element matches with the same target value, because in that case, so we have to return the same index now, correct? Yes, so what we will do, we will return if nums of mid element is equal to target. So if it matches our target, we will return what? Return mid only. Okay. Now else if, we have to check, else if, what if the nums of mid element is greater than target, then we have to search, like shift our search in the towards the left side, correct? Towards the left side. So how we can shift? We will do right is equal to mid -1. Okay, else what we will do? Else we will do we have to shift towards the right side. So hence we have to shift towards the right side. So we will do left is equal to mid plus 1. Okay, and after coming out, suppose if we have not found any equal to case, then left and right both are pointing to the same. Okay, and we will come out of this when left and right crosses each other, correct? So hence we will return the left index. So let's see the code here. First we will initialize our left variable with 0, and then we will initialize our right variable with nums dot length minus 1. Okay, now I want to start my while loop. So we will write while left is less than equal to right. We want to calculate our mid. How we will calculate? Left plus right minus left divide by 2, correct? Divide by 2. Now we want to check key what if our nums of mid element is equal to our target value. In that case we will simply return the mid index. Okay, simply return the mid index. Else if we have to check ki nums of mid, if our nums of mid is greater than target, so in that case nums of mid is greater than target, it means ki our target must be found towards what? Left side, correct? So we have to do right is equal to mid minus 1, correct? Yes. Else our task is to shift towards the right side. So if we want to shift towards the right side, we have to move our left pointer. So we will do mid plus is equal to 1. After coming out of the while loop, we can return our left pointer. And if we will run this, it will pass, and if we will submit this, it will be more faster than the previous one, because there it was taking O of n time complexity and here it is O of log n. But if you think in the O of n also it was 100%, here also it is 100%, what is the difference? It is showing this because of the constraint. Constraint has been given 10 power 4. If it was 10 power 9, the linear would have given us TLE and this would have been given us 100% or like fastest one. So this was a Java code, and here is a Python code with the same logic. Here is a Python language code, and here is your C++ code if you are from C++ background. And if you are still confused ki why only we return this left pointer, why not right pointer, see here also we have multiple solutions. In the multiple way we can return how, like instead of moving this right is equal to mid minus 1, we can move to mid only, and we can save that previous answer and so on. There are a lot of different methods, but I will definitely recommend you all to use your pen and paper and dry run it and see ki why only left, why cannot right, and then you will get to know ki due to some test cases which will fail if you use the right index instead of the left pointer, because here left will always give the correct position, because when left and right crosses each other, definitely right has reached the point where one time left was there, correct, and that was wrong, then only left moves towards right. So hence if you really want to learn that, definitely you should take different test cases and try run it on your own. You will understand key when to use what. And in binary search, most of us confused in the starting phase because of this reason ki we wholly depend on the code instead of writing the logic or code or dry running on your own. So that's it. Now with this we can go in our Rising Brain sheet and we can mark the next question also as to be submitted. I hope you guys are doing with me. If yes, do let me know in the comment section ki done or submitted or understood. And if you feel these videos are really helpful, then I will definitely request you all to share with your friends also, and do hit the like button and subscribe and press a bell icon so that you will get the notification of the next video, because we are doing this on a daily basis. And trust me, even if you're doing along with me without even acknowledging ki yes you are doing, you will learn DSA like this. But simple rule, even if you have watched the video, you have to do the dry run and you have to write the code on your own. Without submitting the code, don't consider that you have learned. Trust me, because for sure you will forget the logic if you have not submitted on your own. So that's it. I hope you learned something new from this video. Let's meet in another video with some more interesting topics and questions. So then keep learning, take care of yourself and your family too.